Welcome everyone to my talk. I'm seeing familiar faces, it's nice. And then thank you for all joining to this talk. My name is Naci Simsek and I'm working as a manager of the customer success technical engineering team at Verberica. We are focusing on the post-sale support of our clients with their Flink use cases, as well as the Verberica platform, Verberica Cloud or BYOC offerings. So without further ado, let's begin our talk. You will see the title Flink Mistake Playbook. So yeah, this is a little bit background about me. I have almost like 17, 18 years experience, which is mostly in the telecommunication companies, including Nortel Networks, Huawei, and then in Germany with Telefonica, focusing on the big data platforms, on-prem clusters, with some, Hadoop clusters, Spark job development, like platform engineering, BI, data warehouse engineering, and then the final 2 years with Verberica, as I just explained, like with the technical account manager, and then final the manager of the post-sale support team. So this talk today, we will be discussing these three topics. As you may remember, the title of the talk, it's a Flink Mistake Playbook. Since we have been working with our clients with their Flink use cases, Flink issues, we have been seeing some common issues that they are commonly facing. So what I'm just touching here is that these 2 years common Flink issues, their, let's say, root causes, so how they can be addressed. So these are like migrating the Flink job from old to the new Kafka connector. This can be any other connectors, but the clients are usually utilizing Kafka, so they are upgrading their Kafka API. So I will be touching the important steps of upgrading the Kafka API, the problem that they might be facing, and the solve of these problems. The second one is distributing the task loads evenly among our task slots. This is also some common issues that we are seeing. And then finally, I will be touching on the points on avoiding the performance issues of the Kryo Fallback. Serialization is really crucial point of the Flink application. So we will be touching those points as well. So I will be focusing on the symptom, like I will be telling you the information of what is the real issue is, and then the root cause of this issue, and finally the solution, or with the recommendations, we will wrap up the session. So this is, you will see here, the old Flink Kafka API, and then this is the new one. So the old Kafka Connector API name is simply Flink Kafka Consumer, and then the new one is the Kafka Source. As you may know, Flink Kafka Consumer is a deprecated API. So we are switching from that API to the Kafka Source API for our, Kafka reading use cases. Why? Because the new Kafka Source API is already been there for quite some time. It has like dynamic partition discovery options. There are many other different options available to the new API is giving us. I'm not going every of those details, but some of them are related with the checkpointing, exactly one semantics, builder, like configuration, new configuration items it has. So this is eventually what we are all going to do if we are utilizing Kafka for our Flink applications. You will see that kind of information in the Flink document, like Flink Kafka Consumer is deprecated and then will be removed in Flink 1.17. Please use Kafka Source instead. Actually, this note is from Flink 1.18 or 19 documentation. So it's still showing up that information to the users. And then the Flink Kafka Consumer API is still there, by the way. Even if you are using Flink 1.19, you will be still able to utilize that old API within the Flink application. So it will be, I think, I'm not sure which particular version it's removed, but it's not actually removed from 1.17, that's for sure. So the symptom or the issue is you are upgrading your Flink application from old to the new API. Nothing wrong with that. Your application is using the new API, keeps using it. Let's say maybe based on your state size, 1 week later or 1 month later, whenever it is, for us, the client is creating a very high severity ticket. They said that their Flink application is not restoring from a save point, because imagine that they upgrade their Kafka API, but 1 month later they will switch to one configuration, which will cause they will utilize a save point. Then the Flink application gives such kind of exception. The RPC invocation size exceeds the maximum akka frame size. Any idea what could be like, what this issue is telling us? I mean, this, for me, as a support engineer, this issue is telling me that increase the maximum akka frame size and you are good to go. Right? Yeah, so we are just increasing the maximum akka frame size. It's okay, by the way, you can increase, your Flink application can restore, but like 2 weeks later on, again, the same issue. Increase the maximum akka frame size. 2 times, 3 times, even 5 times, there are occurrences increasing this maximum akka frame size. But why this akka frame size is just, or not only the akka frame size, but job manager is just like having an out of memory issue. The situation is that, you know, save point is consisting of several bunch of files. What are these files? What is a save point actually? The save point is an underscore metadata file, and then within that metadata file, there are a bunch of other files, right? Like huge sized files. This is a save point. So the save point is not like a .sv file or something like this. This is a bunch of folder. In that folder, you will see an underscore metadata file and some other files. But sometimes there are no other files, only the underscore metadata file based on your inline state kind of configuration. So normally you can expect the underscore metadata file will be a couple kilobytes with this metadata, but it can be gigabytes, like huge size, because it's an inline state file. Every state, operator state, key state is inline in that underscore metadata file. But in this situation, what I would like to tell you is that this underscore metadata file is huge. When the Flink application is restoring from a save point, you know, job manager is utilizing this underscore metadata file. Why? Because what is a save point? To restore the state, right? What job manager needs to do to distribute that state information to each of these task managers, right? Task manager A, your state is this. Task manager B, your state is this. Then each task manager will go to that save point file and utilize those real data files, not the metadata itself. But in this case, metadata file size is big. Why? We will be touching that point. So the underscore metadata file, normal, you know, we have, what kind of state we have? What is a state? State is basically an operator state and then the keyed state, right? Operator state is this. You are reading from Kafka. Operator state is telling you that this is a Kafka topic, this is the partition. That's it. But the keyed state is that you have 1 million key and their aggregated data. This is a keyed state that we have. So in this situation, what causes this underscore metadata file is a huge file is actually an operator state. The operator state is become like that huge to make this underscore metadata file cannot fit into that RPC call, which job manager is exchanging between those task managers. So why this operator state data is too huge? So this is basically the example of how this state looks like. So you see that operator state is the Kafka topic, Kafka partition, and then what is the latest offset for that partition. So imagine that we have 10 partitions, 1 topic, we have only 10 lines of data, even maybe not like some couple kilobyte data. But the keyed state is, yeah, for example, you have a device, count, and some values like the value state, like a keyed state. So this is basically operator and keyed state that I would like to just emphasize. And then here, the situation is that we are switching from old API to the new API. The key problem here is the object type of the old API and then the new API is different. They are not the same object. They are not matching between each other. Since the object type is different, the new Flink application cannot be utilizing the operator state data in that underscore metadata file, which is coming from this old API. So then what is happening then? Yeah, before what's happening, let me just give some distinction between the old and the new KPIs. You will see the state structure, the API, like Flink Kafka Consumer API and the Kafka Source API. State structure is different, like the state name. Partition tracking type is different, like the state management is different. Restore compatibility is even like different, which I'm just focusing in that talk especially. So the situation of this root cause. So this is the implementation of the old API. This is the new API. You will see that every operator has a UID. We are defining why we are defining a UID for every operator. Let's not define. Let Flink handles. The key part that we are defining a UID for every operator is that Flink is utilizing that UID when it's restoring its state, actually. So in this situation, you will see that the problem is that Kafka is like the implementation is using the same UID here. Like the old implementation is Kafka source, new implementation is using the Kafka source UID. The clients are not focusing on changing why we need to change the UID. It's anyway the same Kafka source, right? I mean, not the same API, but it's a Kafka source. Keep the same UID. But the problem is that when we keep the same UID and restore our application from that save point, Flinks start to act like this. It's seeing that kind of state in a save point, but that state, that object is started to become obsolete because my application is not implementing this API anymore. My application is implementing this API. So within the save point file, this state data is like okay for me. This, of course, keyed state is okay for me, but this is not okay for the Flink application anymore. It's an unknown object type inside the state. But this is only like 10 lines of data, right? Some kilobytes of data. Why it's just causing those underscore metadata file size huge? So Flink is started to act like this. You switch from old API to new API, start your Flink application, and your Flink application keeps taking checkpoints, right? For every checkpoint, Flink is copying this 10 lines of data again and again and again. Imagine that you are performing checkpoints every 10 seconds. Every 10 seconds, this inline metadata file is contributing 10 more lines. Again, next 10 seconds, 10 more lines. So you can imagine that after 1 week, 2 weeks, that became a huge sized save point. So this state data started to become like this. Normally we are expecting like 10 lines of state. You see 10 lines here, 10 lines again here, 10 lines again here. It's just copying itself. I just stopped like in 1000, but if I keep my Flink application running, it will be like million lines of obsolete old Kafka API data within that metadata file. You know, in Flink, reading the state is not that easy. But you can always keep in mind that you can use a hexadecimal editor to just simply open this metadata file and see what kind of state object this metadata file has. So this is, you can see I'm using a hexadecimal operator, and I can simply see that topic, partition, offset, states, objects within that metadata file. So this is simply telling me that this save point data is being consisting of a data from an old Kafka API, which is I'm not using anymore because I already switched to the new API. So this is telling the root cause of this bloated old Kafka API state data. So what is the solution? Yeah, this is the situation, you know, job manager is getting this underscore metadata file. The problem is that this is an operator state. Operator states are always kept in that underscore metadata file. This is also another thing that we need to keep in that mind. Operator states are always in that underscore metadata. So it's just simply causing that RPC call failures, or you get the out of memory error. So what's the solution? The first thing is that we need to consider changing the UID. So the UID will be changing from Kafka source to Kafka source new. The new Kafka API will have the new UID. And then, since you have the new UID, your existing save point doesn't know this new UID because your first save point taken on this old API doesn't have this operator UID. So what need you to do is set this allow non-restored state to true for your Flink application. For your Flink application to restore first time with that initial save point. And then there's another problem here. If I change the operator ID to a new name, how my operator is supposed to utilize those offset values from the previous Kafka operator. I cannot utilize the partition, the offset values from the save point anymore. So what needs to be done here is that you basically in your Flink application set a group ID property. Of course, your Kafka consumer will have that particular group. And then you will be setting your offsets, like offsets will be committed for each checkpoint. So offset will be kept in Kafka side for each checkpoint. So you are not depending on the save point file, but you will be depending on your committed offset in the Kafka cluster in this situation. The group ID will be the same group ID, because group ID should be same. You will be utilizing those committed offsets. And then the set starting offset, offset initializer, committed offset. So your Flink application will be initializing itself from those committed offsets. And then UID is having a new UID. So the steps will be, of course, these are the steps which is given in the Flink documentation. But when you will be first reading all these steps, it is not easy to understand or gather what that steps are trying to explain. So these steps are trying to explain, of course, when you switch from old to new Kafka connector, don't at the same time upgrade your Flink version. Keep that same Flink version, 118, 119, 119. Make sure the Kafka consumer has, of course, the group ID set. You will be setting the offset committing for every checkpoint for your previous application. And then you will setting to a new UID. And then your application will be restoring from a non-restored state. Because since you changed the UID, this application's UID, the save point state, will not be useful for you anymore. By the way, this is not only particular for the Kafka API. Flink has an issue to manage these kind of operator UID usage when the object type is changed. So you can see these Flink issues like the Jira tickets for similar issues. It's been still in progress that Flink community is trying to handle that kind of situation automatically within Flink, so you don't need to do anything manually. But what I know is that a couple months ago is still in progress. These are the Flink documentation references of this issue. Since this issue is common, even the steps are given in the Flink documentation. You will see even the Stack Overflow, many information about this. But this is the first ever video which is taken for this one. So for you to reference, I hope nobody will face it, but yeah, that's the situation. The second issue. The second is distributing the load evenly among the task slots. We have the parallelism. We have different task slots. So we are trying to utilize the Flink application as high as possible, right? We don't want some task slots low, some task slot high utilization. So what is the reflection in our Flink job? We have seen this red boxes. We don't want to see this kind of situation mostly. Of course, 70%, 80% is still acceptable business, but 100, what 100 business is causing? Why 100% business is a bad thing? I'm utilizing perfectly. 100% utilizing the task slot, right? Why is it bad? The problem is that 100% business is telling me as a user that set the water of the tap a little bit low, because the sink is going like the water level in the sink is going high up, and then my house is like full of waters everywhere. So I need to switch the top a little bit so the water cannot flow at the same speed, right? So this is actually causing a back pressure on the previous operators. That's make your Flink application high latency, low throughput kind of situation. So we don't want this kind of situations happening. Yeah, this is the situation. There are 4 task slots. Some of the task slots are utilizing that amount of data, but look at this. One task slot is utilizing really high. You will see the business, not all of the operators are having that issue, but this one is utilizing high. You will also see the CPU use times here. So the thing that I will be focusing on here is actually that not like different things that you are trying to distribute your key with key partitioner, rebalancing, some other steps that you can apply to, use maybe Flink SQL to do something automatically for this kind of situation. Local global aggregations. I'm not touching that kind of thing here. I'm just simply focusing on the configuration item called maximum, like max parallelism. This is not being actively utilized by the users. Most of the time it's not needed, because most of the time our key cardinality is high, not that low. But when the key cardinality is low, which I will be touching next, this kind of issues will happen. So what I would like to explain you here is that we have a record. That record has a key, let's say the customer ID. We normally expect this key will be utilized by a task slot, right? But actually between the task slot, like the Flink parallelism, and then the key itself, there is a terminology called key group. Key group. So this key group basically means your max parallelism. So this will look like this. We have a record, we have the keys A, B, C, D, we have the task slots. Our parallelism is 4, so our Flink application has 4 task slots, but my maximum parallelism, max parallelism is 12. So between my task slots and then the keys, there's a key group, 12. Why 12? Because my max parallelism configuration is 12. Actually, max parallelism, what is the default value of the max parallelism? 128, exactly. Here in this example, it's just 12. So you see that key A belongs to this key group, B, C, D. It's a perfect distribution, but the key A has 8 records, so it is a hotkey. This is okay. This is a hotkey. I mean, key cardinality is low, hotkey. But the situation is that in here we have records from key A, key B, but those key A and key B ended up in the same key group. Flink is distributing those keys into the key group and then distributing to the respective task slots. So in this situation, A and B is in the same key. Why? What is causing Flink to assign those 2 keys into that group? This was basically here. There's a formula which Flink utilizes to set those keys into the key groups. In this formula, the situation, what we need to focus is this max parallelism value here. Max parallelism is Flink what is utilizing that value in order to distribute your keys into those key groups. So the situation is that when, in this situation, A and B in the same key group, that means this task slot will have 8 records, will be highly utilized. So in this situation, you will see what I'm trying to explain actually. Let's come to the solution, right? Solution is tweaking the max parallelism value. Tweaking the max parallelism value means tweaking that formula to let Flink to switch a little bit better distribution, so those A and B keys are not belong to the same key groups and eventually not belong to the same task slot. So we will be having an even distribution. You see key A, this is the key group. B and C, the same key group, eventually task slot 0 is highly utilized. Switching the max parallelism value, like double the max parallelism value, simply change that formula, simply distribute key A, B, C in different key groups and eventually in different task slots and eventually utilized task slots among the keys. Of course, not every situation may require the max parallelism value to increase. In this situation, you see even the decrease of the max parallelism can have us from a distribution of utilizing of only 2 key groups out of 4 to 4 key groups will be utilized. So we are not telling always to increase max parallelism or decrease max parallelism. By the way, changing the max parallelism value is not that very simple for every Flink use cases. Changing the max parallelism value requires you to tweak your save point file. So what I would like to refer you is to a Flink talk, get the most out of your task slots subjected talk from Flink, like the previous Flink Forward presentation, which is being done from one of our colleagues, which is really useful talk, which is pointing on that issue. But what I would like to emphasize is that when your key cardinality is high, your probability of even distribution could be high. But the situation when the key cardinality is low, country name, imagine that USA and China will be ended up in the same key slot. That is kind of a situation. So what is the solution is that I don't want you to focus on this text here or this text here. Just focus on this one. Just best practice is keeping the max parallelism value 5 times or 10 times, around 5 and 10 times of your parallelism values. This is what we see is that having with these low cardinality situations kind of an even distribution for your events and then not facing that kind of 100% busy task managers or task slot kind of situation. The third one is that avoiding the performance issues of the Kryo Fallback. Actually, if you didn't set any configuration for your Flink applications, that your Flink application will be throw an exception when it fall back to Kryo, it will fall back to Kryo and still keep working on without any exceptions. But the situation is that this kind of issues, this kind of fallback can cause like high latency, low throughput. So we will be just focusing on that kind of why we are focusing on this kind of serialization in the Flink application so much. Because one task manager and another task manager is two distinct JVMs. Between these two distinct JVMs, we need to serialize those object data in a byte array to perform all these information exchange. And then of course, when the serialization is involved, we would like our Flink application to utilize those serialization as high as possible. Then what we need to consider is that like applying the serialization which is high performant. There are lists comparing all the serialization kind of types and then their performances between each other. But what we are focusing on here is that if our object types are like primitive types, string, long, integer, we have like using arrays, composite types or POJO types, we are utilizing a high performance serializer. Of course, we are also having Avro, like a thrift protobuf kind of serialization logics that we can apply, but all other types is just falling back to the Kryo serialization. This is taken from one of the old Flink versions. Of course, there are some newer comparisons, but this is mostly the same. It's just focusing on like tuple POJO is having a high, let's say, throughput utilization. But if you're falling back to Kryo, your Flink application performance is reducing. So how it's reflecting? It's reflecting this kind of info logs. By the way, these are info logs. These are not an exception logs. It's just telling that your application cannot be used POJO type because not all fields are the valid POJO fields. It will be processed as generic type. Field XXX something will be processed as generic type. Like your application missing a default constructor, your class, so it cannot be performed as a POJO type, it will be a generic type. So these are telling something to us. You can, by the way, see the similar information in the flame graph. Flame graph will also reflect the Kryo kind of fallback in itself, so you can identify. So why it's been happening? This is an order record, which is having all these primitive types, but it will also have a type called list. So this list is kind of an unknown type for the Flink application. What we need to do is to, define this to the Flink application in order to apply, like, there's a box, there's an Amazon box, there are shoes, there are perfumes. I would like to give like the shoes to this cluster, perfumes to this cluster, but for example, when the box comes, I know this is shoe. Immediately pass it. This is a perfume, immediately pass it. But imagine that Kryo fallback, I don't know if that box is a shoe or perfume or anything. When the event comes, I need to open it. It's a shoe. I need to open again the new event. It's a perfume. So this opening kind of thing is what making Kryo not perform better. So the situation is that you can reduce some of those events if it's not useful for your application. Reducing the utilized kind of an information for your order record like this can improve the performance of your Flink application. This is one thing. Another thing is that if you are utilizing Kafka for your analytical use cases as an event source, there will be many talk around Flus. You can utilize Flus for that kind of situation. It will be giving you much better performance. But for this kind of situation, we have this list type. What we need to utilize the POJO serialization in this situation is that defining this as a list info factory, which is extending the type info factory. So what this code part is basically doing is that putting a label on that Amazon box, which is telling what kind of type which is inside in that box. So our serialization doesn't need to open when that box comes every time. So it will be simply utilizing the POJO serialization and then it will perform well. So this is the actual solution, what you will need to apply when you see that kind of generic type kind of info logs. Your, of course, class must be public in order to apply as a POJO. It needs a no argument constructor. This will definitely require for the deserialization. you will, if your fields are private, they all need to have the getter setters. Of course, you need to have the concrete types, or for any other types which is not defined, you need to use that type info for generics. And then if you set kind of configuration like disable generic types, your application will not show those info logs. Simply throw an exception for you to handle that kind of situation to keep your Flink application performance always at top. So this is the summary. We were touching the migration from old Flink connector to the new one, distributing the load evenly of our task slots, and then finally avoiding the performance issues of the Kryo Fallback. So I would like to say thank you for this talk. I'm happy for all of you to come here and listen. So if you have any questions, I'm glad to answer. Thank you.